Hello student. Now here we are talking about the optical isomerism. Optical isomerism is a type of isomerism where the molecular have the same molecular formula and structural formula, but they are differ in the arrangement of their atom in space, making them the non-superimposable mirror images of each other, and it is known as the enantiomers. There are two types, that is we call as the enantiomers and distereoisomers. So what are the enantiomers? Enantiomers are nothing but they are the non-superimposable mirror images of each other, and that's why they are called as the enantiomers. And other is the diisomerism. So first of all, we'll talk about the what is the meaning of the enantiomers. Okay, so for the enantiomer, I can take one example to explain, that is 2-butanol. 2-butanol, I can write this 2-butanol. This is butane. At there is a hydroxyl group present here, and rest of the group as it is. Now, my question is to you, how many chiral carbon atoms are present here? So there are 4 carbon. This is not a chiral, but this is a chiral carbon. Why? Because there are 4 different atoms or group of atoms are attached. There is one CH3 group, here is OH, here is hydrox, and here is an ethyl group. So that's why there is one chiral carbon atoms are present. So those compound which shows the chiral carbon atom, they are called as optically active, means they can rotate the plane of plane polarized light. So it shows these are called as the enantiomers. So if I write the structure of this compound and I can show that how their mirror images are superimposed, so I can write here CH2, CH3. This side I can take this hydrogen, here is OH group, and here is the CH3 group. We will put a mirror in between. Suppose this is the mirror, and how its image looks like. So this is as it is. Now this hydrogen comes here, then there is OH group as it is here. So these are the two mirror images, and these two mirror images are not superimposed. Okay, means if I take this and as it is I put it here, they are not superimposed. Like means my two palm. This is my one palm and this is my another palm. So they are mirror images of each other, but if I put on them, so they are non-superimposed. Okay, so non-superimposable mirror images are called as the enantiomers. Okay, so these enantiomers are of two type. One is we called as the dextrorotatory compound, that is D form, and another is we can called as the L form. D means dextro rotatory compound and L means Leo rotatory compound. Again, this D is small d is designated as plus and this is designated as minus. But these are the optical rotation we can measure with the help of the polarimeter. Okay. So one is we call as dextro and another is a Leo. So these are the enantiomer. Now what is the meaning of the distereoisomers? Okay, so these distereoisomers are nothing but again they are the stereoisomers, and these stereoisomers they are having the same molecular formula and sequence of the bonded element, but which are non-superimposable, non-mirror images. Okay, and that's why they are called as the distereoisomer. We will take an example of distereoisomer is the 2,3 dichloro butane. This is example we'll take. So first of all, we'll write the structure of this one. It is butane, and here is a 2 comma 3, means here is again Cl, here is again Cl, and then rest of the groups are as it is. So this is the 2,3 dichloro, we called as it is a butane. Now, how we can show these distereoisomers for these two compounds? So for that we have to write the Fischer projection formula. We can understand very well with the help of this. So I can draw it here, one CS3 in Fischer. Here is again your CS3, and there are two double bond. And if I take Cl this side, this Cl, and these are the two hydrogen atoms. Okay, now you can see this is a chiral carbon, this is again a chiral carbon. So there are two chiral carbon atoms are present here, and in these two chiral carbon atoms they have the different isomers. So I can take the another isomer of this, again this CS3 and CS3, and we will have this two different. I can take Cl this side, Cl this side, and here is the H and H. So both these compounds are nothing but the 2,3 dichlorobutane. But what is the difference? You can see it here. Here also two chiral centers are present here. But you can see they not mirror images of each other. ये दोनों mirror image भी नहीं है, and they are not the as an object. They are also not a similar. Okay, because there is a difference, and that's why they are called as the distereoisomers. Okay, it means they have the same molecular formula, and sequence of the bonded element also same, but they are non-superimposable as an object, or they are not the mirror images of each other. So that's why you can see this is not a mirror image of this, or they are not superimposable also, but they are, that's why they are called as the distereoisomers. Okay, and it means their properties are again is a different. So there is another nomenclature system is exists for this compound. If the similar group presents same side in the Fischer projection, we called as erythro, and if the similar group present opposite side, we called as the trios. Suppose this Cl here and this Cl here, and in the Fischer projection they are present opposite side, they are called as the trios. So this is the nomenclature system, that is erythro and trio, which can be applicable for the distereoisomerism compounds. So thank you.